Hello class, today we're going to talk about section 10.3, which is operations with radical expressions. When we're talking about adding and subtraction of rational expressions, you're going to treat the radicals like a variable. So if you have 4x plus 2x, we know that that would give us a total of 6x. Same thing happens with these radicals, or these square roots. If I have 4 square roots of 5, and I am adding 2 square roots of 5, that means I have 6 square roots of 5. The same rules also apply, so if I had 4x plus 2y, that's as simplified as we can go. We can't combine those like terms. Similar thing would happen if I had 4 square roots of 5 plus 2 square roots of 3. That's as simple as we can go because 5 and 3 don't match. So when you're looking to add and subtract radicals, you need to try and get them to have matching square roots. So looking here, we've got 10 square roots of 7 plus 5 square roots of 11 minus 4 square roots of 7 minus 6 square roots of 11. So the first thing you're going to want to do is get these matching radicals next to each other. So I've got 10 square roots of 7. Then I've got minus 4 square roots of 7, because this negative 4 can move next to the 10. Then I've got plus 5 square roots of 11 minus 6 square roots of 11. So I simply rearranged so our matching pieces were together. Now I put together what I can. 10 square roots of 7 minus 4 square roots of 7 gives me 6 square roots of 7. 5 square roots of 11 minus 6 square roots of 11 gives me negative 1 square root of 11. That is all the farther I can go because 7 and 11 do not match. Go ahead and try this one on your own, resuming the video when you are ready to go. 5 plus 7 gives me 12 minus 6 gives me 6 square roots of 2. Sometimes we have to do a little simplifying before we can do the addition or subtraction. So 18, 32, and 72 do not match. However, they can all be simplified. So I'm going to take 2 square root of 18 and break it into 2 square root of 9 square root of 2. So using that concept we had yesterday of breaking up and dividing by perfect squares. So then I'm going to look at the next piece and I'm going to say plus 2 square root of 16 square root of 2. So now we see a pattern. We've got a 2 in the first part and a 2 in the second part. Then I want to check to see if 72 can be divided by 2. It can, and that gives me 36 square roots of 2. So now we're going to go ahead and solve the pieces that we can. So we've got 2 times 3 square root of 2, because I took the square root of 9 and got 3, plus 2 times 4 square root of 2 by taking the square root of 16. And then I've got plus 6 square roots of 2, because the square root of 36 is 6. 3 times 2 gives me 6 square roots of 2, plus 2 times 4 gives me 8 square roots of 2, plus we have already simplified the back part to 6 square roots of 2. So then I've got 6 plus 8, which is 14, plus another 6, gives me a total of 20 square roots of 2. So even though this initial problem didn't look like it could be added, we needed to simplify, break down each of those square roots, and then do the addition at the end. Go ahead and try this one on your own, pausing and resuming the video when you are ready to go. So I can break down 45 into 9 and 5, 20 into 4 and 5, and 245 into 49 and 5. Simplifying each of those pieces, I end up with 9 square roots of 5 plus 2 square roots of 5 minus 7 square roots of 5. 9 plus 2 is 11. Minus 7 gives me 4 square roots of 5 for a final answer. Other things that we can do with square roots is multiply them. Again, we're going to treat them like a variable. So if I have 3x times 5y, I get 15xy. When I'm looking at square roots, I multiply the numbers outside the square roots, which is going to give me 15 outside the square root. And then inside, I've got x and y. So anything outside the square root is going to stay outside when you multiply. Anything inside is going to stay inside. So when we're looking at this, I've got a 3 on the outside and a 2 on the outside. Those get multiplied first. So 3 times 2 gives me 6. Then on the inside, I've got a 2 and a 6, which is going to give me the square root of 12. Then to finish this problem, we want to check for simplification. I can split 12 into 4 and 3. Once I do that, I can take the square root of 4, which gives me 6 times 2 square roots of 3. 6 times 2 is going to give me 12 for a final answer of 12 square roots of 3. So multiply the outside numbers, 2 times 3. Multiply the inside numbers, 2 times 6, which is 12. Simplifying 12 down, I end up with 12 square roots of 3. Try this one on your own, resuming the video when you are done. Multiply the inside and the outside. Simplifying that inside piece down, we end up with 495 square roots of 3. Last piece we need to look at is when there is a distributive property. This looks like a lot of numbers, so sometimes I find it easier to break it into 2 pieces. So I've got 3 square roots of 5 times the first piece, which is 2 square roots of 5, plus the second piece, which again is 3 square roots of 5. So we're distributing plus multiplied with 5 square roots of 3. So we're going to take those outside pieces, 2 times 3, which gives me 6. Square root of 5 times 5 is 25. Then I'm going to go ahead and do the second part. Outside pieces, 3 times 5 gives me 15. Square root of 3 times 5, which is 15. I can solve the square root of 25 and get an answer of 5. So I've got 6 times 5 plus 15 can't be broken down, so I've got 15 square roots of 15, giving me my final answer of 30 plus 15 square roots of 15. You cannot add 30 and 15 because 30 does not have a square root with it. Go ahead and try this one on your own, resuming the video when you are done. So multiplying the outsides, 3 times 4 is 12, 2 times 3 is 6. That maintains. Then I've got 3 times 6 is 18, 2 times 2 is 4. So that gives me 18 square roots of 4. We can solve the square root of 4 and multiply to get 12 square roots of 6 plus 36. Now that you are done with the video, show your notes to the sub and get your homework slip.